Okay, so welcome to binary operations and number bases. So this is a combination of number bases and binary operations. In a previous lesson, we were looking at tables where you have multiplication table and addition table. In this case, uh, you will be given what binary operation. And as you know, in binary operation, the rule will be given to you. So you really need to what? Apply the rule, substitute whatever set, the values you have in your set. You just substitute, get your answer, and then you apply the base. Okay, good. So this one, when the question is given to you, all that you need to do is first, you look for the rule given in the question. For instance, this question before us, we have this rule P operation or Q, which is equal to 5p squared minus Q. So this is the rule given to us. Okay, so in questions like this, what you do is if the set is given, which in this case we have the set given here. If the set is not given, then you base on the base given to generate your set. So if here in this question, if we had not been given the set as 1, 2, 3, 4, what would be our set? We would have started from what? 0. That means we will write 0, 1, 2, 3, 4, 5, 6, and 7. We'll end at 7. That will be what? Our rule. But in this case, we have been given what? The set as only these numbers. So once you are given this set, you don't need to generate it in a set again. All right, good. Now, so once you identify your rule given in the question, you just pick the values in the set, you substitute, get your value. After getting your value, whatever answer you get, it's already in base 10. As I told you when we began the number base, I said that whenever the number stands alone or doesn't have any base, it means that that number is in base 10. So when it is in base 10, then you need to change it to base 8, and you know how to use it. We will still apply what? The remainder principle. Okay, so still you realize that all that we have been doing, the remainder principle what runs through, and this one to apply that. All right, good. So without wasting my time, let's see how we can solve this question. So first of all, we know that this is the rule given. We have P operation Q, which is equal to 5p squared minus what? Q. Good. So this is the rule given to us. So what you are going to do is that in A we are saying we should draw what? A table for the operation on the set that. So we are going to draw our table and see how we can fill out the spaces in the table. All right, good. So this is our table. Now how are we going to fill this table? So we are going to substitute these values into the row and solve. So it means that I will use all these values to represent my P and all these values to represent my hot Q. So it means that if I pick 1, if I pick 1 for P, then I'll pick this one for Q. So whatever value I get, I put it here. If I pick 1 for P, I'll pick 2 for Q. So that is how we are going to do it. So on the first we shall look at this. So write 1 operation 1 is equal to, so it means that this is P and this is what? Q. So whenever I see P in the equation or in the rule, I will substitute 1. Whenever I see Q, I will substitute this one. That's the case. Then I have my 1 squared minus 1, and this gives us what? 4, because the 1 squared is 1 times 5 is 5 minus 1 is 4. So it means that after getting the answer, this is what you have gotten. Then you look at the base given. So you were given base 8. So since we have 4 and the 4 is less than 8, then we can just write the 4. Then we pick 1 and 2. So my P is what? 1. My Q is what? 2. So it means that this squared is what? 1 times 5. 5 minus 2 gives me what? 3. And 3 is also less than 8. So I'll write my 3. I'll pick 1 star 3, which is equal to 5. 1 squared minus 3. And here becomes what? 2. So it means that here is 2. If here is, so you see that it's following a pattern. If here is 4, here is 3, here is 2, then I'll get here to be 1. Have you gotten that? Great. So let's continue with the rest of the table. So we have, so this time we are done with the 1. So I'm going to pick 2. So it means that if I pick 2 and pick 1 here, the 2 is for P and the 1 is for what? Q. So if I pick 2 star 1, then I'll write 5 multiplying 2 squared minus 1. Okay, great. Make sure you don't see, because here is 1 2 we got 3, so here 2 1 you are getting, no, here we are not talking about commutativity. Here there is no commutativity here because of the negative you see here. Okay, and also because of this 5 here. So please take note of this. All right, good. So it means that this, if I take square of this, this is what? This is 4. Okay, 4 times 5 gives me 20. So 20 minus 1 gives me what? 19. Okay, so this is 19. Now, you have 19. 19 is greater than 8, the base which is given in the question. Okay, so once the base is 8, then we need to use the remainder principle. Okay, so we can just write our 8 here like we did, and then we have 19 here, then remainder. Okay, so this is the remainder principle. We are still using remainder principle. So it means that when 8 divides 19, how many times? So we know that we are going to get 2 remainder 3. So this is what you have gotten. 2 is less than 8, so we can end there. So it means that we have for this 2 3. So it means that here will be 2 3. Have you gotten the point? Good. Now I will choose 2 star. So this time 2 star 2, which will give me 5 multiplying 2 squared minus 2. Okay, so 2 squared is 4 times this is what? 20 minus 2 is equal to 18. So if I use the remainder principle, it means that 8 divides 18 how many times? 2, remainder what? 2. So it means that here will be 2 2. So if you realize that this is 2 3 and this is 2 2, then definitely here should be what? 2 1, and here should be what? 2 0. So we move on to 3. So you realize that when you are doing it, it follows a pattern like that. Okay, so all that you do is you pick this, you pick its counterpart, you substitute to the rule given. Okay, you substitute to the rule given, then the answer you get, you apply what? The base, or you change to the base given, which is in base 8, and that's what you will do until you are done filling what? Every empty box. Okay, so that is how it is done. So let's quickly fill in the rest of the empty boxes. Great. So that is the values that we have here. So when you have it like this, that is how you go about it. Now let's quickly look at the rest of the questions given. Okay. So for the B part, we are asked to use the table to evaluate. So we are to evaluate. So for B, we have to evaluate what? 2 operation 3. So this one, very simple. You just use your table where 2 is and where 3 is. So it means that 2 operation 3. What is the answer? 2 operation 3 gives us what? 21. Okay, so this one is very simple. And then we have I. For I we have 2 operation 4 operation 1. Now, as I said, always you need to tackle what is in the bracket first. So let's check what is 2 operation 4. So 2 operation 4 gives us what? 20 star 1. Okay, now here we come again. Since the question also asks us to use the table, so we have to look for where 20 is. So you realize that we don't also have 20 in the set given. So that's why we can conclude that no solution. Good. Because the question restricted us to use the table. So if you want to use the table, then you can't find any 20 here or 20 here, even though we have 20 in the table as our answer, but not in the set. Okay, yes, because the set was given as 1, 2, 3, 4. So you need to make sure that whatever values you are going to use should be in the domain of the set given, but 20 is not there. That's why we are saying no solution. All right, now let's also look at the C, where we have Ci. We are to find the truth set of A star 2 is equal to 5, 3. Good. So in this one, you also look for where you can locate 5, 3 or 53, and where you have 2. So you see that this is what? My 5, 3 here. So I will trace it to the vertical part to identify where 2 is. So this is 2, then to the horizontal part, which is 3. So it means that 3 operation 2 gives me what? 5, 3. If that's the case, then what is my truth set? It means that A is equal to what? 3. Therefore, the truth set is giving us A is such that A is equal to 3. That's it. Now let's look at the last part, which is I. That is A star A is equal to 22. So this one too, it means that the value operating with each self gives me what? 22. So let me go back to the table and see where I can locate 22. So if you check, you see that this is 22. Then you locate from your vertical part and your horizontal part. So you see that you get your 2 here, you get another 2 here. So it means that 2 and 2 gives me the 22, because we are saying A and A gives me what? 22. Therefore, it's going to be 2 star 2, which gives us what? 22. Then A is equal to what? 2. So we conclude that therefore the truth set is giving us A is such that A is equal to 2, and that answers the question. Okay, so that is about the binary operation with number base. So we are done. This will be our last example on number basis. There are a lot of examples that we can look at. So my dear students, I will urge you to solve more examples. Okay, all right. So we shall meet again in our next video. Bye bye.